Thank you very much for inviting me and for the nice introduction. So yeah, my first slide is the obligatory conflict of interest slide. I have no known conflicts of interest regarding the content of this presentation, but I want to just mention that parts of the work presented here were supported by the Research Commission at the Medical Faculty at the University of Freiburg in Germany. So what I'm going to talk about today in this webinar is, so you can see the agenda here. At first, I would like to give some background on risk of bias assessment and on artificial intelligence, and especially what I am going to talk about today. And then I would like to present you some results and also some methods of our study where we tested the large language model Claude for assessing randomized controlled trials with the ROB2 tool. And then I would like to compare our results to those of other studies, and hopefully this will be quite interesting for many of you. And yes, then I would just finish my talk with a short discussion and conclusion. So that's what I will present today. First of all, I would like to give you some background regarding risk of bias assessment, also not too much, but I would like to say that in this webinar, I'm focusing primarily on assessing randomized controlled trials and using the revised Cochrane risk of bias tool. One moment, I will change. So this is what I wanted to do. Sorry. So I will mainly focus on the ROB2 tool, but I would also like to mention that there's a previous version of this Cochrane risk of bias tool, also sometimes called ROB1, but which is not really recommended to use it today, but it still gets used quite often. Therefore, this also will be a topic today in this talk. And you can see the figure here, and I think most of you will be familiar with those types of figures. So what you can see here is a risk of bias assessment conducted with the ROB2 tool of 2 studies at outcome levels. You can see here the response options of the risk of bias tool, so low risk of bias, high risk of bias, and some concerns. And what you can also see here is the 5 domains of the ROB2, and there is also an overall domain. So this is how ROB2 is, so the content of ROB2. I only want to mention very briefly that there, of course, are a lot of other risk of bias tools, especially also for other study types. For example, Robbins I. And the reason why I'm mentioning this is that I would briefly like to come to this later, because there's also a study in which large language models were tested for conducting Robbins I assessment. Therefore, just to mention it, Robbins I tool. So next, I would like to give you some very brief background on artificial intelligence and especially large language models. So just some basic information. I mainly use the term large language models when I'm talking about, or when I'm saying AI, artificial intelligence, I mainly mean large language models, but also I also will talk a little bit about more traditional machine learning, but only, yes, not too much about this. So the main focus will be large language models. As you may know, large language models are trained on huge amounts of data, and they always predict the most likely next token. So, for example, the most likely next text occurring to a given text. And what is really important, or what is really also makes it so easy, is that large language models do not need task-specific training for conducting any task. So this, of course, makes them very, very useful. And the other important thing, which I'm sure you have already noted when using, for example, ChatGPT, is that they can be used without any programming knowledge. So you can just give instruction in natural language and will receive a result. And yes, just to mention some examples, I have already mentioned ChatGPT. I'm sure all of you may know it, and Claude, which we used for our testing, but of course there are also many more large language models. So, for example, Gemini, or yeah, quite a lot. I think I don't need to mention them at this point. So, starting with the machine learning, so more traditional machine learning for risk of bias assessment. So what I would like to show you first here is a figure from a mapping review conducted in 2022, or published in 2022, conducted in 2021 by Pierre Jimenez. What he did is that he summarized all kinds of machine learning approaches that facilitate systematic review production, so support the conduct of systematic reviews. And as you can see here, already in 2021, there were quite a lot of machine learning tools available, for example, for searching or screening. But what is interesting is that there was only one tool to support the critical appraisal of studies, so the risk of bias assessment, which is the robot reviewer. And interestingly, as far as I know, there's also today not really another approach or another machine learning approach to support risk of bias assessment than the robot reviewer. Continuing with large language models, I would also like to show you one figure, and this is a figure of the recent scoping review I conducted with my colleagues, where we, looked for approaches using large language models for different, for supporting different systematic review steps. You can see here the different systematic review steps. Here, these bubbles are studies we identified, and what we did is that we categorized them according to the study author's conclusions into promising, neutral, or non-promising. And yes, if you have a look just at the risk of bias section here, you can see that, yes, there are not, or at this point in February 2024, when we conducted our search, we did not identify so many applications of large language models for risk of bias assessment. And what is also maybe interesting is that yes, so how promising the conclusions of the authors were, it was quite variable. So we had some non-promising, two non-promising approaches, but also two promising. And yeah, so it's not really clear from this work how good it works, how promising risk of bias assessment is. So the next thing I would like to present or talk about is our study where we tested the large language model Claude for assessing randomized controlled trials using the revised Cochrane risk of bias tool. And this work has just been published quite recently. It has also not been included into the scoping review we conducted. So in this so we don't have this study included here. Yes, so what did we do? We searched for Cochrane reviews in the Cochrane library, and we searched for Cochrane reviews in which the risk of bias tool, the Cochrane risk of bias tool, the revised version, was already used, which are not that many, or are still not that many, because as I mentioned, ROB1 is still used quite commonly. And so we draw a random sample of 100 RCTs from those 78 Cochrane reviews we were able to identify at this time in October 2023. And so from these Cochrane reviews, we had already risk of bias assessments conducted by the Cochrane reviewers, and we took this risk of bias assessment as reference standard. And what we did next is that we provided those reports of RCTs, so the studies, to Claude, and instructed Claude to produce risk of bias assessments for these RCTs. And the next step was simply, comparing the judgments of the Cochrane reviewers with the judgments of Claude. And this was more or less our study design. I would like to give you some information on our prompt, because I think this is maybe something which is interesting to many of you. So prompting, I'm sure most of you will know what a prompt is. So it's just the task you give to the large language models in natural language, just in normal language. And we conducted a quite long pilot phase where we did prompt engineering to find out what the most suitable prompt could be, or how it could look like for risk of bias assessment using the ROB2 tool. And we tested all those prompts we developed using a sample of 30 RCTs from 3 Cochrane reviews. And of course, we excluded those 3 Cochrane reviews from the main testing then. And I would like to show you some of our prompt principles we finally applied. As I mentioned, it took us quite long to find a working prompt, because at the beginning the results were really, really bad. Then it got a bit better when we applied those principles. So the first thing was that we learned that it's helpful to have separate prompts for each risk of bias domain. So just putting everything into one prompt and sending it to Claude, it was not really good. It did not work well. And then the second thing was that we had to specify the study outcome for which risk of bias should be assessed. The reason for this is that the ROB2 tool is applied on the outcome level. And first, when we did not specify the outcome, we just got a random selection of outcomes for which Claude produced the risk of bias assessment, for example, for missing outcome data, but it was not the outcome which was assessed in the Cochrane review. So we had a problem here. We had to provide for each study, we had to provide the outcome to Claude. Then we learned that it is helpful to include ROB2 guidance and provide also quite detailed instruction. And our approach was to not mention the name of the tool, so not mentioning ROB2 as a tool, because we were hoping that we could avoid a simple recall of results. Yes, so just let me explain this a little bit. The training data, so Claude has been trained, of course, with a lot of data, and we were suspecting that Cochrane reviews may be also in the training data of Claude. We don't know, but it could be. And to avoid that, Claude simply takes the judgments out of its training data. We decided to not mention this tool, but instead give quite detailed instruction. And the last thing I would like to mention is that we learned that it is helpful to compress the study protocols and register entries. We also provided those study protocols and register entries to Claude, because this is this is necessary to check, for example, for selective reporting. But the problem is that many protocols have 100 pages or even more. So if you have 100 pages of protocol and finally maybe 15 pages of the main manuscript, it's just imbalanced, and that did not work quite well. So we compressed it, and I will show you in the next slides how we did this more or less. So finally, we had a chain of prompts, of zero-shot prompts, and yes, so you can maybe imagine that manual copy-pasting of this many prompts and also upload the protocols and so on, that it would have been quite unfeasible for 100 RCTs and also error-prone, and this was the reason why a colleague of mine created a custom program, which is shown here as an overview. There's no need to understand everything in detail. I will quickly show you the different steps of this program. So what we did, what we prompted Claude to do. So the first thing was that we instructed Claude to extract the relevant details from the protocols and the register entries, if there were any. And here is an excerpt of the prompt. So yes, I give you a clinical trials protocol, and as this protocol is quite lengthy, your job is to sum it up to the bare essentials that are needed to answer questions from the following domains. So this is how it looked like. The next thing was that we prompted Claude to assess each risk of bias domain separately, so each of the 5 domains. Yes, also here another excerpt of the prompt. Your critical review of clinical trials reports, and your only task is to assess the risk of bias arising from the randomization process, for example, in the manuscript. The next step was that we prompted Claude to do some kind of self-check or self-review. This looked like this. So we told Claude, I give you the risk of bias evaluation, including justifications. So these were the risk of bias evaluation Claude already produced for the 5 domains. Your task is to check the reviewer's assessments. If the assessment does not look like it is justified, you are free to override the reviewer's assessment. So again, we provided all the guidance, and we provided the assessments already created by Claude. And this was something which we had the impression during the prompt engineering that it worked quite well, because Claude often was quite strict at the beginning, and then it got a bit better with this additional prompt. And so this was the last step where we produced, or Claude produced, the overall rating, the overall risk of bias rating. Here's again an example, an excerpt of the prompt. You are a critical review of clinical trials reports. Your task is to assess the overall risk of bias based on the risk of bias assessment given. So we provided again the judgments for the 5 domains, as you would do it as a human, and then Claude applied the algorithm which we provided to Claude, and then produced the overall risk of bias assessment. So here are some results of our testing. For the overall judgment first, here you can see how often Cochrane reviews judged low risk, some concerns, and high risks. And here you see the same for Claude. And as you can see, it differed a little bit. And I have to mention that for the 5 individual domains, it also looked a little bit different. We had much more low risk of bias judgment for the single domains. So it was quite interesting that single domains had really a lot of low risk of judgment of Cochrane reviews and Claude. So we had quite imbalanced data. but which is at this point maybe more interesting is having a look at the confusion matrix here. So you see here judgments of Claude, here the judgments of the Cochrane reviewers, and in the red marked fields you have those decisions where there was an agreement. So, for example, low risk judged by the Cochrane review authors and low risk judged by Claude 18. Yes, and in the other fields, you see that we have the disagreements, for example, here also 18, where Claude judged some concerns, but Cochrane review authors judged low risk. So yes, maybe as you can see here, the agreement was not that good. And I show you the percent of agreement, which you can also, which is the accuracy. So we had agreement between 41% and 71%, which at the first glance, maybe it looks not that bad, but when we calculated Cohen's kappa, which is, of course, a bit of more robust measure than the simple percent of agreement, yes, you can just see that the values are really low. And just to give you a rough interpretation of Cohen's kappa, we can say that we have slight agreement, maybe in some points, up to fair, but yes, so it's quite low agreement, not so good iterator reliability, not so good agreement. What we did, or what we also did, is that we prompted Claude to produce justification for each of its assessment at the domain level. So this is why we could also manually review the discrepancies. And I hope that it will be interesting for you to see where the problems were, maybe. So we had, for example, with randomization, a problem that Claude was often not able to check the lack of allocation concealment, or also to detect that information is missing on allocation concealment. And for the second domain, there was a problem that the potential impact of lacking blinding of participants or carers was interpreted in a different manner by Claude and the Cochrane reviewers. So, for example, Claude said some concerns because of the lack of blinding, and the Cochrane review authors, they regarded this as quite unlikely that there were any deviations from the intended interventions because of an open label design. So next, the third domain, missing data. Here we had two problems often. The first was interpreting the potential impact of missing data again. So how serious was the absence of data, and then also detecting available data, where Claude often or sometimes was not able to find missing data or to see that data was missing. And here, the fourth domain, it was again also detecting the absence of assessor blinding of outcomes assessor, and also interpreting the impact of non-blinded assessors. And I have a little example here of this is the risk of bias judgment for domain 4 by the Cochrane reviewers and Claude for a randomized controlled trial on acute care of frail elderly patients in a comprehensive geriatric assessment unit, so on a specialized ward. And as you can see here, the outcome measure assessed was the ADL staircase, which is a combination of interview and observation to assess difficulties with activities of daily living. And Cochrane reviews said, okay, the ADL staircase is considered appropriate, there were no differences in the measurement or ascertainment between groups, but the assessors were not blinded, and it was therefore considered likely that knowledge of the intervention could influence the outcome. Yeah, so they judged high risk. And what is really interesting here is that Claude provided nearly the same information, so also that the measurement method was appropriate, it did not differ between groups, and Claude also detected the assessor knowledge of intervention so that the assessors were not blinded, but Claude interpreted that it was unlikely to impact the standardized ideal staircase rating, so that the results may be not affected by the knowledge of the intervention. And I think this is a quite interesting example, because we can see here that the information is correct in both cases, of course. So, but the interpretation is a real problem. And this is something quite unique for risk of bias assessment. For example, if you compare that to data extraction for systematic reviews, you don't have to interpret the data when you do data extraction. So this is a very special feature of risk of bias assessment. And I just will go back to this slide. So one example for the last risk of bias domain of selective reporting. So there, a common problem was to detect the absence or presence of a pre-specified protocol or analysis plan, so that Claude just did not detect that there was a protocol, for example. The overall judgment, we checked whether the overall judgment was in line with the algorithm provided to Claude, the algorithm contained in the ROB2 guidance, which is a quite simple one. And it was interesting that Claude largely followed this guidance. So only 2 out of 100 judgments deviated from the given algorithm. So this worked quite well. So I promised that I will compare our results to those of other studies, and I hope this will be now quite interesting for you. I would like to first compare it to more traditional machine learning approaches, which is more or less the robot reviewer, as I already said. Then I would like to compare it to other studies using large language model approaches, so for example, ChatGPT. And then I would also like to compare it with human risk of bias judgment and how well humans agree when they make risk of bias judgment. So first of all, the robot reviewer, which produces ROB1 results, so the previous version of the Cochrane risk of bias tool. And there are quite a lot of testings of robot reviewer. I just picked some of the most informative ones from my point of view. And so we have 3 studies here I would like to quickly show you. They all assessed quite a lot of randomized controlled trials using the robot reviewer. And here you can see which reference standard they use. So these 2 also use Cochrane review risk of bias assessment. So risk of bias assessments taken from Cochrane reviews. And this study used own risk of bias judgments. And you can see here the % of agreement and also Cohen's kappa. And as you may see here, it is also not that good. And I have to add that also they concentrated only, all of these 3 studies concentrated only of the first 4 domains of the risk of bias tool. And if you compare it to our results for the first 4 domains here, it is, agreement is maybe quite comparable, but Cohen's kappa values were lower in our testing. So we can maybe say that the robot reviewer produces better results than our testing, still not good enough to be used as a standard alone tool. And most important, it only produces judgments using the old risk of bias tool, which may be not that helpful. So here are some results of other studies using LLM approaches. And first of all, Peter et al. They used a quite similar approach as we did, but they used GPT-4 as a model and not Claude. But the other things were quite similar. They also took Cochrane reviews as a reference standard. And as you can see here, they even had lower agreement rates than in OR testing, but Cohen's kappa was comparable to OR testing. And here just one sentence of the conclusions. We recommend systematic reviewers avoid using ChatGPT to perform risk of bias assessments. So not really optimistic statement at the end. And here's a further study by Hassan et al. And what is interesting is that they use the Robbins I tool, as I mentioned before, a tool to assess non-randomized studies of intervention. They also used GPT-4, and they also took Cochrane reviews as a reference standard. And as you can see here, agreement is a bit higher, but still the Cohen's kappa is quite low. And here again, I have the conclusion of Hassan et al., or one sentence of the conclusion. Considering the agreement level with a human reviewer in the case study, pairing AI with an independent human reviewer remains required at present. Yeah, which is already optimistic. So pairing AI, but yeah, I would say the results are also not that promising. Here is a further study by Schuster et al. And they also took the ROB2 tool, but they tested a bit more models. So GPT was there, Flam T5XL, and there were also two fine-tuned LLMs, so fine-tuned with using medical data, so especially for the medical area. And unfortunately, they did not provide those numbers, percentage agreement and kappa, but they provided F1 values. But as you can see, this is also not so good. These values are also quite low. Yeah. And here are their conclusion, or one sentence of their conclusion: using LLMs as an assisting technology for assessing ROB2 thus currently seems beyond their reach. So also not so optimistic. But I have found two further studies by Lai and colleagues. So it was the same author group for both studies, which were really, really interesting to see. Because as you look here first, at the results, you can see that the results are really, really good, incredibly good, I think. So we have nearly perfect agreement here, or nearly or really perfect agreement, Cohen's kappa value of 1.0, 100% of agreement, which is just really, really good. And yes, so they applied GPT, Claude, also here a Chinese LLM. But so where could be the differences? Why did they produce so different results? I cannot really tell, but I can just tell what were differences to the approaches, to the other approaches. So what they did is they used a modified version of ROB1, which is perhaps quite easy to apply, I guess. So maybe this is a reason for the discrepancy. And what is also interesting is that they used own risk of bias judgment as a reference standard, even though they also had an external reference standard, because they took the studies from systematic reviews with given risk of bias assessment, but they decided to produce own judgments as a reference standard. This is something I don't know whether this is a reason or can be a reason for the better agreement, but it is a difference. So here is the conclusion of these authors. So of course it was much more optimistic. We demonstrated substantial accuracy and consistency in evaluating RCTs, suggesting their potential as supportive tools in systematic review processes. So, and I see that I'm already talking quite a little bit, so I maybe have to go on a bit more quickly. What I would like to show you, and this is the last thing I would like to show you, is how humans perform with risk of bias assessment. And sorry, I would like to show you a study or two studies from Minossi et al. They assessed randomized controlled trials using the ROB2 tools, and they were 4 reviewers, and they calculated inter-rater agreement. So this is the reason why they calculated Fleisch's kappa, because there were 4 reviewers. Interpretation is quite similar to Cohen's kappa. And as you can see here, the inter-rater reliability was also quite low. So this means that also human assessors were not really good at agreeing with each other in risk of bias assessment. And this is a further study Minossi et al. Conducted. And in this study, they performed a calibration exercise. And they assessed 5 studies before this calibration exercise, which and obtained quite bad agreement. And then they developed an implementation document with instructions on how to answer the signaling questions, and all the 4 reviewers agreed on how they will perform the risk of bias assessment. So they made additional just arranged additional instructions. And as you can see here, the results were really much better. And I also have the original table here that you can see how much better the results really were. So have a look at this first gray row. You can see that we often have kappa values with a minus in front, so really, really bad. And here in the lower gray row, you can see that it just got much better, the agreement. And this is interesting because it maybe means that the guidance is not, it's just not enough. You need additional instructions, and authors have to make additional instructions. So I don't want to bore you with any more numbers, but of course there are also studies comparing human agreement for ROB1 tools. And as I can only say, and you may see from these titles, is that also humans are not so good in agreeing with the ROB1 tool, or using the ROB1 tool. They are not good in agreeing with each other. Yes, which brings me to the last slide, to the discussion section, to a quick discussion. So some open questions and maybe next steps. So the one really big question, I think, is what reference standard should we use? Because there obviously is no perfect reference standard for risk of bias assessment. No true risk of bias assessment are available. So maybe we should use an expert reference standard created by 10 people or so, very experienced people and so on. But I think also this could maybe also introduce bias at some point. And yes, one next question is maybe that we could also think of other forms of support than creating full risk of bias judgments. So for example, it would be more feasible to extract the relevant data we need for risk of bias assessment. Just an idea, maybe we could use only risk of bias domains that are most promising, but still the question is which domains are most promising, because this is also not consistent between studies. And I would like just to mention that we, of course, should strive for high methodological quality, because this is not always given in those types of studies. Just one last mention, you may have noted that there has been released a new risk of bias tool, Robust RCT, it is called, and so it is said to be much easier to apply. I don't know because I haven't tested it by myself, but it will be maybe interesting how humans will perform on that, how the agreement between humans will be, and how also will LLMs be able to conduct risk bias assessment using this tool. So yeah, just to conclude, one sentence: currently using LLMs for risk bias assessment is not recommended from my point of view and from the results I presented here. And yes, so some acknowledgements here. Of course, all this work would not have been possible without my colleagues. So thanks to my colleagues, and here is my contact, my email address. So if you have any questions after this talk, so just contact me.